Pardon? Okay, so back in the booklet, 4.6 Exponent Laws. So really it's just kind of like a combination of everything that we've done so far. So it shouldn't be too hard today. And if you've missed a lesson along the way, then this is a good catch up to make sure you understand the rules. So this part says simplify by writing as a single power. It says explain the reasoning, but we'll talk about the reasoning instead. And what we're going to do is we're going to write all our answers with a positive exponent. Okay. So let's look. So this is going back to the rules. And we went over exponent rules. Gentlemen, hi. Hey. I think back in, we did it in 4.4. So we did these rules. The product of powers, the quotient of powers, and the power of a power. You did those in grade 9. But if you didn't remember them, they are in 4.4, and we'll just talk about them briefly as we go through. All right, so part A. The only time I can apply the rules is when they have the exact same base. So do these have the exact same base? Yes, they do. So I keep my base of 0.3, and if they're being multiplied, what do I do to the exponents?
Add.
I add them.
So 0.3 squared?
So I'm going to write that down. You do not have to write this step down. You could jump to this step. Now you can choose to have the brackets on it or not, because it's just one thing in the base. It doesn't have a negative sign, or it's not a fraction. See, this is equivalent to that. But I like to put it in brackets because sometimes people will just look at that really quick and they'll think 3 squared and they'll say the answer is 9, which it's not, because it's a decimal point. So this question, we're just writing them as a single power, writing as a single power with a positive exponent. Okay, sliding over. Part B, way more exponents happening here. So I'm going to deal with this one first. And then I'm going to deal with this one next. So we're going to apply a couple different exponent laws to this one. So let's look at the pink first. So that's a power of a power. So what's the rule when you have an exponent to an exponent? What do we do to them? You multiply them. So you're going to multiply the exponents. So we're going to keep the base of negative 3 over 2. And negative 4 times by a positive 2 is going to give me a negative 8. And that's multiplied. There's a little dot in there. And then now we're going to go to the orange, and we're going to do the same because it's a power to a power. So an exponent to another exponent. We're going to keep the base of negative 3 over 2. And we're going to multiply 2 times 3, which is 6. And now we're at this stage. So this is an important stage. You do have to write this step. Now we're going to look at them, and this is the exact same thing as part A was, right? Same bases, and now we have same bases, and we're going to add the exponents together. So we're going to keep the base of negative 3 over 2. This must be put in brackets because there's a negative sign, and then there's a denominator and numerator, so we've got to keep those. And now we have to write this as a positive exponent. Everybody know how I got the negative 2? Yeah? I just added negative 8 plus 6, and that left me with a negative 2. Okay? If you need to write that down in your notes somewhere, you probably should. Oh, maybe I'll do it too, just so we have full and complete notes.
Full and complete?
And I'm okay if you go from here to here. You don't have to write this step in. I'm okay if you go from here to here if you know your rules. So I want to write it as a positive exponent. How do I do that? What does the negative tell me to do? This was yesterday's lesson. We got to flip the base. Does it change the base to a positive number? No, it does not. Has no effect on that. So we're going to flip the base. So that's going to be 2 over negative 3 to the exponent positive 2. Okay. All right. So that was like a couple lessons all. That was 4-4. That was 4-5b. So much to do. Okay, so now we're going to add some stuff in. When you're dealing with these fractions, you have to treat this like there's a big bracket on the top. You're going to want to get that one to a single exponent, and then you're going to want to deal with some stuff. Do you need a unit circle? You good? Okay. All right, so they have the same base. We're just looking at that numerator right now. They have the same base, so we're going to keep it. And what are we going to do to the exponents? If they're multiplied together, we're going to add them. So that's going to be to the 7th. My denominator is to the negative 2. So now I have a single exponent on top. Sorry, I have a single power on top, and I have a single power on the bottom. Now I can apply the quotient rule. So if they're the exact same base, I keep the base. And what do I do to the exponents?
1.49?
Nope. I do.
You're supposed to minus them, but in this place.
Okay, so what did I ask? What do you do to the exponents? Thanks. That's all I was looking for. Subtract. You're 6 steps ahead, man. Like, slow down. We're going through this. So when it's the quotient rule, we're going to subtract. So it's going to be 7 minus a negative 2. So when you have a subtract, or when you have a subtracted negative, you're going to add the opposite. So 1.4 to the exponent 9. And that's a positive, so we can leave it there. Oof. This one has a lot of things in it. A lot of things in it. Okay, first thing I'm going to do is I'm going to deal with this denominator first. And now we've added fractions in, which was less than 4.4. So we're going to keep the numerator of 7 2/3. The denominator, we're going to keep the base of 7, and we're going to add the exponents. Okay, they both have denominators of 3. So that's good. I don't have to find a common denominator. So I'm going to have 6 over 3, and then that's all to the exponent 6. How do I get what?
How do you get 6?
What's 1 plus 5? 6. Okay, that's how I got it. So when you're adding fractions, they have to have a common denominator, but I think we all know that. Yes. So this one can be simplified, right? You guys agree with me? Yes? I would save yourself some heartache, and when you can, I would simplify.
Let's go.
Okay, so now, before I do anything with that power outside, I can deal with this power first, but I don't want to. I want to get it down to a single power inside the bracket. So now I'm going to do that quotient rule again. So the quotient rule says I got to subtract them. So I'm going to have 7 2/3 minus 2 to the exponent 6. What do I need when I'm subtracting fractions? What do I need when I'm adding fractions?
LCM.
Okay, yeah. LCD, lowest common denominator?
Yes.
Okay, so has to have a denominator of 3, right? This one has a denominator of 3, this one needs a denominator of 3. So I'm going to times the numerator and the denominator by 3. So I'm going to have 7 exponent 2/3 minus 6 over 3. Oh, maybe it would have been better just to leave it instead of simplifying it. And that's all to the exponent 6. So I'm left with 7 to the negative 4/3 to the exponent 6. Okay, so we've done the product law, we've done the quotient law, and now we're about to do the power law. So we've done all 3 laws in this question. This is a really nice question for a quiz because I can test on all 3 different things inside one question. No? Not a good. Chelsea's saying that's not a good plan. Okay, multiplying fractions. 6 can be written as a fraction by putting it over 1. But you guys all know that because we've talked about that. And with multiplying fractions, straight across the top in the numerators, multiplied by straight across the bottom in the denominators. So 7 to the exponent negative 24 over 3. We're going to reduce that. 8 over 1. So we can just say 8, right?
7.
Do you guys, okay, just, again, like, you're throwing out answers that aren't at the right spot. And you're confusing us. So all we did was we reduced this fraction to get the negative 8. We're going to write it as a positive exponent. So this is my base number of 7. The negative tells me to flip my base. So that's going to be 1/7 to the exponent positive 8. Jonah's still sick? Jonah's still sick? Well, you were texting him all yesterday.
Yeah, he's still sick.
Okay, I was just asking. You have your finger on the pulse. You were in India. That's what I found out about you.
Yeah.
So I didn't feel that was accurate knowledge.
I know.
Yeah, you went to India for a week?
Of course.
Oh, who doesn't?
It's going to be quite a long practice. Me and Takumi went to India together.
Oh, funny. He was here. I saw him every day. He's got a long commute. Not him, not that guy, not that Taku. The other Taku.
You me, right? No, I'm not going with you.
Okay, all right. I'm a little traumatized by this. All right, so you guys actually have done your exponent rules already because when we multiply polynomials, you essentially apply them. So when we're multiplying things with multiple variables, we're going to look at the x's first because those have same bases. So it's going to be x to the exponent 3 plus 2 multiplied by y to the 2 plus negative 4. What? You do the thing.
You hop over.
You leapfrog it?
Yeah, leapfrog.
Yeah. But there's no different terms. There's no add in here. So it's just a monomial times by a monomial. Do you know what a monomial is?
Yeah.
It's a single term. No add or subtract in them. So we've got x to the exponent 5, y to the exponent negative 2. We want to write it with a positive exponent. So this one's going to switch to x to the exponent 5 times by 1 over y to the exponent 2. Now you could go one step further. And write it like that. Oftentimes that's the way you're going to see it written. So 1 squared is 1, and y squared is y squared. So I'd have x over 5 times 1 over y squared. And when we multiply fractions, straight across the top, straight across the bottom. This is usually the format that you'll see it in. Just saying. So that one's a little bit different because we're using letters. And although that feels uncomfortable, it's the same stuff that you do when you're using numbers. Okay, you guys ready to do the next one? Yes? No? Go ahead. This is a division question. So what are you doing to all the exponents?
Minus.
You're minusing them. Subtracting. But with the numbers, what are we going to do with the numbers?
Simplify.
We're going to simplify. So what's the same as 10 over 2? What's 10 divided by 2? 5. And then you're going to have a to the exponent 5 minus 2 and b to the exponent 3 minus a negative 2. Deanna, you're getting any of this done?
I don't think,
Oh, okay.
see all my stuff, I don't keep it all. Please write it down here.
Am I good to flip the page?
Wait.
How do you get to do 5?
Yes, you just take pictures.
Oh.
Okay. Oh, these ones are tricky. They're not really tricky. You just got to remember a piece. So power of a power. What are we doing with the exponents in a power of a power? When we are multiplying, we add them. When we're dividing, we minus them. When we subtract them. And when we're exponent to an exponent, what do?
Multiply.
We multiply them. But here's the thing. What's the exponent on the 2? It's invisible. The invisible 1. And a lot of people forget that they have to apply the exponent to the coefficient. So this is going to be 2, 1 times 3, x, 4 times 3, y, negative 2 times 3. So super duper important that you don't forget that coefficient. And you guys all know what the coefficient is, right?
8.
The coefficient, when I'm talking about that, is the number 2. All right, so 2 to the exponent 3, x to the exponent 12, y to the exponent negative 6. So we're going to evaluate that coefficient. So 2 to the exponent 3 is 8. X to the exponent 12. We want to write it as a positive exponent. So what's going to happen here? This is going to be 1 over y to the exponent 6. I guess I should write it like this. Let me write it like this. Right? Because the negative exponent tells us to flip that base. And then we'd have 8 x to the exponent 12, 1 to the exponent 6. My pen's dying. Oh, made a comeback. It's okay. What's 1 to the exponent 6? 1. So we're going to have 8 x to the exponent 12 times 1 over y to the exponent 6. And if we were to multiply that through, that would be 8 x to the exponent 12, y to the exponent 6. Okay, I'm going to let you guys do the next one with the fractions in it. Give it a shot. Try it.
It's not funny, man. It's not funny, God. Man, like, this good. That's the right one? Oh, let me get that wrong. Alright, I got it. Now, when you're doing like.
Mr. Collins,
Sure.
for the
Denominator.
yeah, for that thingy, if it's an exponent, the thingy, which I can't say, that is the root.
Yes, it is. Yeah, that's the root. Pardon?
That's boxing.
Okay. I'm going to show you where I am partway through.
What?
Yep. I do. You're very capable. Very capable.
That's exactly what I remember. Yes, Sam. Oh, I think I can forget. Yeah.
So all I did was I did the same thing I did on the other question. I multiplied that exponent through the brackets. I multiplied it by the exponent of every part in the brackets. So that's what I did. Fractions, it's just numerators times numerators, denominators times denominators. So this one's like 4 over 1. That's supposed to be a 1. So really easy. Anything times by 1 is itself. This one here, 1 times negative 2 is negative 2. 2 times 3 is 6. And then 4 times negative 2 is negative 8. And 1 times 3 is 3. Okay, so that line should be good. Like, you guys should be able to do that and be okay with it. Because that's just multiplying it through.
Yeah, I got it.
Next line, I dealt with the negative exponents. So I dealt with the negative, and all that means to do is flip my base. So if it was 8, now it's 1 over 8. If it was x, it's now 1 over x. If it was y, it's now 1 over y. And then you just drop that negative from the exponents. So that's all I've done so far. It looks pretty yicky, but it's not too terrible. No, it's not.
Miss Gallion, I agree with Chelsea today. It is terrible.
Okay. Remember that in fractional exponents, the bottom tells you what kind of root you have, and the top tells you your exponent. Okay? So it tells you the kind of root and tells you the exponent that you have. And that's for all of them. I just wrote it in a place that I could see it. Okay, so I have a cube root and I have a squared. I'm going to take the cube root of 8. I'm going to take the cube root of 1, and then I'm going to square it. This one is going to be the cube root of 1 and the cube root of x. And this one's going to be, oh, and that's all to the exponent 1. Did I have to write to the exponent 1? No, anything to the exponent 1 is itself. I feel like I'm here by myself today. Okay.
Miss Gallion, other days I'm usually energetic, but today this is going over my head.
Why? It's just everything that we've done pulled into one lesson.
Yeah, it's like, imagine if Santa Claus, Jesus, and like your friends attended the same party. It's like that.
Okay.
And
Hadn't thought about Jesus attending a party. All right. So what's the cube root of 1? Guys, what's the cube root of 1? It's 1. What's the cube root of 8? 2.
What?
Cube root of 8. Oh.
You guys told me the cube root of 1 is 1, and I cannot take the cube root of x, so I'm just going to leave it like that. Well, that's a cube root, by the way.
Running with that space.
You'll be okay. I'm making sure I show you every single line. This is going to be 1 over the cube root of y, but it's to the exponent 8. Okay, what's 1/2 squared, everybody? What's 1 squared? 1. What's 2 squared? 4. Okay, nothing I can do here. And there's nothing, I can't take the cube root of y either, so this is going to be 1 over the cube root. Whoa, that's a bad index. Lose a half mark right there.
For what?
For my bad index.
Can you show me what it looks like?
No, I just erased it. So if you didn't notice, then I'm going to show you my...
Are we giving these half marks?
Okay. So those, I'm just going to go ahead and multiply everything on the bottom. Because these are the same indexes, I can multiply what's under the root sign. So you ready for the magic? That's okay. That's okay.
How do you get 4?
Because of this one's over 4.
No, but like 8,
Well, you can actually see the marks too.
Sure.
We're doing stuff now. Think out of it.
Sorry, normally I get time to
No,
study,
that's
but this week is going forward for me.
Why'd you get 2?
Because I cubed the 8.
Okay. You cube root the 8, but okay. Oh, you did it this way. Okay, that's good. But the square is just on the 8. It's not under the root sign. Huh? The 1/2 is just on the x, not on the 8 as well. So that 8 shouldn't be under the root sign.
Could you please keep the X? No.
Take a picture. All right. All right.
Taking pictures of girls.
Stallion! Could you please go up?
Here, come take a picture of the page. Come take a picture of the page. Whew, why am I in trouble?
Suspended.
I'm gonna suspend you for not doing notes.
Suspend me, yeah.
And you know what your punishment is gonna be? It's gonna be an in-school suspension writing all the notes. All day. All day.
I'll make it right.
Okay.
I'll make Dion break it. Yeah, Dion.
Okay.
I don't want to hear you.
So this one is a two-stepper. Two-stepper word problem.
More?
Two-stepper word problem. So a sphere, you guys know what a sphere is? It's a ball. Has a volume of 540 cubic meters. So volume equals 540 cubic meters. We know volume is 3-dimension. So the unit should be 3-dimension. So then the question's asking, what's the surface area of the sphere to the nearest square meter? So we have a little bit of information. We know that the volume of a sphere is represented by 4/3 pi r cubed. We know what V is. It was given to us in the question. We need to solve for r because we need to use r to find our surface area. So we need to solve for r. So we're going to put in 540 in here. So now we need to get r by itself.
No, Miss Kelly,
Not yet.
I have an awesome
Can't yet.
idea. First, let's do 540 divided by 4/3, which equals to pi divided by r cubed.
Nope, but he's right. He's right. So we got to get r by itself. So we need to get rid of all of this stuff. Nope. It's a good thing I'm using. Oh, I'm erasing everything now. Oh dear. I'm erasing everything. Okay, we need to get rid of that. Because we want to get r by itself. Eventually we want r by itself. Right now we're going to work on getting r cubed isolated to one side.
What is that middle U?
Pardon? That's pi. Oh, you don't like it? You don't like my symbol?
Isn't like five?
So if I were to walk over there, what would your symbol look like? Is it better than mine?
It's better.
Is it better?
You don't even
Is this kind of like an airplane?
Mine's better.
God.
Miss Kelly, that symbol is beautiful.
Thanks. Okay. So this is, would you guys agree that this is divide by 3 on the right-hand side? Thank you. Thanks, Chelsea. Thanks for sticking with me on this one. So the opposite operation of divide is multiply. So if I multiply this side by 3, I have to multiply that side by 3. So that's going to get rid of those. 16, 20?
It's got the scooper too.
Okay. You need to put that away and just like pretend. Pretend you're doing math. You're not.
What? You know, Steve has a party with
Yeah.
Okay. So now I need to get rid of the 4 pi. And would you guys all agree that pi is just a number? It is a delicious pastry. But in math, the symbol represents just 3.14159. Keeps going and going forever. So it's just a number. So we're going to divide, because these are all multiply, so opposite operation is divide. So we're going to divide this side by 4 pi. And we're going to divide this side by 4 pi.
I'm such an idiot.
Ooh, sorry, 128. So I don't want r cubed, I just want r. So how do I get rid of that cubed?
No, you put 128 for that one, you
Not negative 3, because that's 1/3. And so what is that? It's a cube root. So Steve just made the connection. We want r to the exponent 1. So really, we need to put this to an exponent of 1/3. Because what's 1/3 times by 3? 3 over 3, which is 1. So if I put this to an exponent of 1/3, I got to put that to an exponent of 1/3. What does that represent? That's a cube root, ladies and gentlemen.
5.0516700903.
Oh, sorry, just moving over here.
How long does pi go for?
It's infinite.
How do they know that?
Because they've written major computer programs to let it run forever and ever and ever.
I don't understand pi is not like, oh,
Oh, do you want to know what it is? Okay, so any perfect circle,
yeah, I'm thinking of the circle.
okay, any perfect circle, you take the circumference,
Yeah.
divided by the diameter.
Circumference is
Circles the perimeter on the outside
divided.
by the diameter. You will always get pi.
Holy! Circumference divided by the diameter, which is how, if you have a massive computer, you can
That is
calculate.
not how computers were made. I'm not getting this info.
Miss Gallen, you just blew the world up.
It's what I do. Okay, so that gives me R. Now with that piece of information, I can now use the surface area formula. So the surface area formula is given here as 4 pi r squared. And I can just substitute it into that and solve for surface area. So I'm going to ask that you guys do that. Okay? Pretty basic. Plug and chug. Somebody give the woman a calculator.
Give me a calculator!
We're not. Big mouth bass. What summer are we on? 4.5?
4.6 today.
Oh yeah, it's the.
Miss Gallen, your math classes are actually lit.
I like to think so, but Rahat, I think we are in small company.
What?
I don't think other people would say the same.
No. Yeah, it's alright.
Well, I mean, I have to
We survive. We survive.
I dropped 30 on P4.
Where's the time button?
Exactly, my calculator is so annoying. Miss Gallen, in calculus in grade 11, we chucked the calculator into the recycling, right?
What the hell's that?
You need to go and ask for your birthday for a nice calculator.
Oh, I found the.
I highly recommend the TI-30X. It's just a nice little scientific calculator.
Yeah, I mean, this thing is so annoying, I want to choke it out of the roast.
I don't know if this is the right answer.
What applies?
Okay, are you guys ready to see the right answer?
Yeah.
320.6859733.
What?
How?
I got it right. Holy moly.
That's what I'm doing.
So what it said to the nearest square meter, so to the no decimal places.
What's the little 26 under there?
That's the page number. If you had your book out, you'd know.
I do have my book out.
Do you see the 26?
Yeah, I see it.
There you go.
That doesn't look like.
I really got it.
Oh,
Are
yeah.
you proud of me?
These papers.
Don't turn it.
All right.
Sorry, you're-
So this is a complicated lesson.